List View.Builder. The List View.Builder widget in Flutter is a powerful and efficient way to create a scrollable list of items, especially when dealing with a potentially large or dynamic data set. This widget utilizes the builder pattern, which is instrumental in optimizing performance by only creating the widgets that are currently visible on the screen, plus a few extras to ensure smooth scrolling. When developing applications, particularly mobile ones where resources are limited, performance and memory management are critical factors. The List View.Builder addresses these concerns effectively by rendering items lazily. This means that it does not construct all the list items up front, which can lead to significant memory usage and slower performance, especially in scenarios involving hundreds or thousands of items. The structure of List View.Builder is straightforward yet flexible. It requires two primary parameters, item count and item builder. The item count parameter indicates how many items the list should contain. This is essential for performance, as it allows the builder to understand the extent of the list it needs to create. The item builder parameter is a callback function that provides the logic for building each item in the list. This function takes two arguments, the context and the index of the item being built. The index allows for dynamic content rendering, meaning each item can be customized based on its position in the list, whether it's pulling data from a local database, an API, or other sources. For example, when building a list of articles, you might retrieve a list of titles and summaries from a remote server. Each time the item builder is called, it can access the corresponding article's data using the index, ensuring that the correct title and summary are displayed in the list item. This dynamic rendering not only enhances the user experience by providing timely data but also reduces the initial load time, as the app only needs to create the widgets for items that are visible to the user at any given moment. Furthermore, List View.Builder supports different types of layouts. You can customize the appearance of the items by incorporating various Flutter widgets within the item builder. For instance, you might want to include images, text, and buttons, all styled according to your application's theme. Additionally, List View.Builder can be easily combined with other Flutter widgets to create more complex layouts. For example, you can nest it within a column or a stack, or wrap it in a container for additional styling. This flexibility allows developers to create visually appealing and functional user interfaces tailored to the application's specific needs. Moreover, it integrates seamlessly with state management solutions like Provider, Block, or Riverpod, enabling efficient handling of dynamic data updates. For instance, if your application needs to display a list of user-generated content that updates in real time, you can leverage these state management solutions to ensure that the List View.Builder reflects changes instantly, without requiring a complete rebuild of the widget tree. Another essential feature of List View.Builder is its ability to support item animations. You can enhance user interactions by adding animations that occur when items are added, removed, or updated within the list. Using the animated list widget in conjunction with List View.Builder allows developers to create smooth transitions that can greatly improve the user experience. For example, if an item is removed from the list, you can animate its disappearance, which helps maintain a visual connection and provides feedback to the user about the change. This level of interactivity is crucial in modern applications where user engagement is paramount. When it comes to handling user interactions within the list, List View.Builder also provides options for gesture detection. You can wrap each list item in a gesture detector or an inkwell widget to detect taps or swipes, enabling actions such as navigating to a detail page, deleting an item, or revealing more options. This interactivity enhances the usability of the application, making it more intuitive for users. Furthermore, you can implement infinite scrolling by combining List View.Builder with a pagination strategy. This approach involves detecting when the user has scrolled to the end of the list and then fetching more data from a server or database, thereby creating a seamless experience that keeps users engaged without overwhelming them with too much information at once. In conclusion, the List View.Builder widget is an invaluable tool in the Flutter framework, providing developers with the ability to create efficient, scalable, and interactive lists that can handle dynamic data sets. Its lazy loading approach, combined with the flexibility to customize item layouts and handle user interactions, makes it an essential component for building modern applications. As mobile users increasingly expect fast and responsive interfaces, mastering the List View.Builder will undoubtedly enhance the overall quality of your Flutter applications. HTTP package. The HTTP package in Dart is a fundamental library that facilitates making network requests within Flutter applications. In today's app development landscape, where applications often rely on external data sources such as web APIs, understanding how to effectively utilize the HTTP package is crucial for building dynamic, data-driven applications. The HTTP package provides a simple and intuitive interface for sending and receiving data over the internet, making it easier for developers to interact with RESTful services and integrate remote data into their applications. This package supports various types of HTTP methods, including GET, POST, PUT, DELETE, and more, allowing for a wide range of interactions with web services. One of the key features of the HTTP package is its asynchronous nature. When making network requests, it is essential to ensure that the user interface remains responsive. The HTTP package provides asynchronous methods, such as GET, POST, PUT, and DELETE, which return a future object. This allows developers to perform network operations without blocking the main thread, which is vital for maintaining a smooth user experience. For example, when fetching data from a remote server, you can use the await keyword to pause the execution until the data is received while keeping the UI responsive in the meantime. This approach is crucial in mobile applications, where long wait times can lead to a poor user experience and high app abandonment rates. Another significant advantage of the HTTP package is its support for handling responses. When you make a request, the HTTP package returns a response object, which contains important information such as the status code, headers, and the body of the response. Developers can easily check the status code to determine whether the request was successful, status codes 200 to 299, or if an error occurred, status codes 400 to 599. This feature allows for effective error handling strategies. For instance, you can display an error message to the user or retry the request based on the type of error encountered. Additionally, the HTTP package supports various response formats, including JSON, which is widely used in web APIs. Developers can use the Dart Convert library to decode JSON responses easily, transforming them into Dart objects for further manipulation. Security is another critical aspect of using the HTTP package, especially when handling sensitive data. The package allows for HTTPS requests, ensuring that data transmitted over the network is encrypted and secure. When making requests, developers can specify the protocol, HTTP or HTTPS, to ensure that they are using secure connections. Furthermore, the package supports additional security features, such as custom headers, which can be useful for passing authentication tokens or other metadata required by the server. This is particularly important in applications that require user authentication or access to secure resources, where ensuring data privacy is paramount. Caching is another feature that can enhance the performance of network requests. Although the HTTP package itself does not provide built-in caching, developers can implement caching strategies using additional libraries or by managing cached responses manually. Caching previously fetched data can significantly reduce network load and improve response times, especially for applications that frequently access the same data. For example, if your app retrieves a list of products from an online store, caching this data can allow users to access it quickly without repeated requests to the server. In addition to basic network requests, the HTTP package also supports multi-part requests, which are essential for uploading files or images. When users need to upload content, such as profile pictures or documents, you can easily create multi-part requests to send files alongside other form data. This functionality is crucial for applications that require user-generated content, allowing seamless interaction with backend services. Moreover, the HTTP package can be easily integrated with state management solutions. For instance, you can use provider or block to manage the state of your application based on the data fetched from the server. This integration allows for a clean separation of concerns, making your application more maintainable and scalable. By managing API calls within a dedicated service or repository layer, you can ensure that your UI components remain focused on presentation and user interaction. Error handling is crucial when working with network requests.
The end.